So here's the last test I'll be doing. It's to determine the effects of different voltages on the circuit with the same difference in voltage between the two voltages. So I have a total of 4 balance circuits I can use, as well as a total of 12 battery cells I can use. And then I will be having 3 groups. Let's go over to my spreadsheet here. Group number 1 will have 1 cell on one side and 2 cells on the other, so a difference in voltage of 3.4 volts, or the voltage of the individual battery cells. Group B will have 2 cells and 3 cells. And then Group C, because I'm limited to a voltage of approximately 10 volts into the circuit because of the way I'm doing my gate drive, will have 1 cell on one side, 2 cells on the other, but with a D-cell battery on each cell. So it'll give me a difference in voltage of 3.4 volts, but an amplitude of the voltages between groups A and groups B. I'll then perform a statistical analysis of the 3 groups to determine if there is a significant difference, which will show me the effects of the different voltages on the circuit with the same difference in voltage. So running through what I have here, this is a setup for one of group A. So for this particular one, I'm using balance circuits 2 and 4 in cells 10, 11, and 12. I've randomized my selection of battery cells and in balance circuits in order to accurately portray the total population of all the different cells. I'm probing a resistor, across a resistor in this isolated parallel bus. It's a bunch of parallel 2.2 ohm resistors, resulting in 0.2 ohms approximately. And then I turn on the circuit, and then I can look at that voltage, and I am paying attention to this maximum point here. I can zoom in a lot more on it. Put ground reference near the bottom, and that gives me the maximum current in my bus. Then I can measure that. And I will do that for 10 trials for every group, and then compare the groups. So there's the test.